Okay, we have only 2 more problems left on our area between 2 curves, so we're going to go ahead and get those knocked out today. Asks us to find the area bounded by the x-axis and y equals x squared minus 2x. So the first thing we're going to do is graph that. We know this is a parabola. We have a couple of key features that we can figure out. One is we can find out the intercepts. So I'm going to go ahead and set y equal to 0 and find the x-intercepts, since this is so easy to factor. Okay, so we could just factor out an x. That leaves us x minus 2. Set each one of those equal to 0. And we easily know then that we have intercepts at 0 and 2. So I'm going to graph that. Okay, so we have 0, 0, and 2, 0. And I'm expecting this to be a parabola going up since the coefficient of x squared is positive. I can find the x-coordinate of the vertex in one of 2 ways. One is I can say I know it's got to be right in the middle between these 2 intercepts. The other is that I could use the formula x equals negative b over 2a. But it appears to me to be pretty simple to go right between 0 and 2, so I know that the x-coordinate is 1 for the vertex. And then I can just substitute that into this, so it would be y equals 1 squared minus 2 times 1. So negative 1, so I know the vertex is at 1, negative 1. So I've got a pretty good picture of what this looks like. And they want the region bounded by that and the x-axis. Okay, so here's the x-axis, and here's my curve. And I want this area in between, so I'm just going to shade that in. And we're going to integrate, these are our bounds, are going from 0 to 2 of the top curve minus the bottom curve. So the top curve in this case is the x-axis, and that has equation y equals 0. So the top curve would be 0 minus the bottom curve is just our parabola, x squared minus 2x. So minus x squared minus 2x dx. Okay. Now, if you'll remember, we talked about anytime you had integration and it was under the curve, that your value came out to be negative. So you'll see what's happening here is we're just taking the opposite of the integral of this, which is changing it to positive and allowing us to find our area. Again, we don't have to think through all of that. We can just say top curve minus the bottom curve. Top curve is y equals 0 minus the bottom curve is x squared minus 2x. Okay, so that's pretty easy to integrate. We're just doing the integral from 0 to 2. I'm going to go ahead and distribute my negative. Negative x squared plus 2x. Okay, if we integrate negative x squared, we'd get negative 1/3 x cubed plus x squared from 0 to 2. Substitute 2 in, your upper bound all the way through. You would have negative 8/3 plus 4. Minus what you get when you substitute the lower bound 0 all the way through, which is just 0. So this would just be negative 8/3 plus 12/3, which is 4/3. Sorry for running off the screen there. Okay, so we have found that this area in here is 4/3. Okay, the last one we're going to do is going to be done with the calculator. Finally, time to utilize that. And so I'm going to just, it's going to again be bound by the x-axis and this curve, x cubed plus 2x squared minus 3x. Okay, so what I'm going to do is just graph those. Okay, we're going to do this one all calculator based. So I'm going to graph x cubed plus 2x squared. Oops, looks like I let too much of that be my exponent. Needed to go down there. Plus 2x squared minus 3x. Okay, so I want the area bounded by that curve and also the x-axis. So I'm just going to go ahead and graph y equals 0. And basically I've got 2 areas here. I've got this area and this area in here. So I'm just going to see. I'm having a little trouble with my Promethean, so it may not. Oh, it's doing okay. We're going to try to find this as one area. Alright, I got the perfectionists in the audience that are probably noticing little dots that are not colored in. Try to bear with me. Okay, so we have two areas there. Okay, we have this area and this area. And what you'll notice is it changes which curve is on top. So for this first area, the curve is on top, the y-axis is on the bottom. On the second little region, we have the x-axis on top and the curve on the bottom. So we're going to have to divide it into two different regions in order to figure this out. And what I need to do is find these bounds, this one, and this one, which are actually just the zeros of the function. Okay, so what I'm going to do is just go to my menu, Analyze Graph, go to the zeros. It's asking me of which graph, and so I need to click on my cubic function. It's asking for a lower bound, so I'm going to click to the left and then to the right of that first point. Then I'm going to repeat the process for each of the others. So menu, Analyze Graph, 0. Click the graph again, go to the left and the right. Good old 0, 0. Oops, click that off. And let's see, I seem to have a lot going on here. Let's see if I can get rid of that. And one more point, menu, Analyze Graph, 0. Click the graph, click to the left and the right. Okay, so it looks like I've got -3, 0, 0, 0, and 1, 0. Okay, so what I'll do then is I'm just going to make a quick little sketch of that on my paper. So take a minute and sketch that. I'll be sketching at my paper and I'll show you that sketch in just a minute. But go ahead and sketch your zeros, -3, 0, 0, 0, and 1, 0. It's often good to graph key points like the maxes and the mins. I'm going to keep it simple on this one. Okay, and we're going to just click over to that now. Okay, so this was our basic shape. And this is region 1. And this is region 2. Okay, and so what we're going to do for the first region is we're going to integrate from -3 to 0. The top curve is going to be x cubed plus 2x squared minus 3x minus the bottom curve, which is just the x-axis, or 0. Okay, and then we're going to add to that the integral from 0 to 1, and the curve on top this time is just the x-axis. So the equation for that is 0 minus the equation of the curve again. So it just switched which one was on top. So if you think about it, all we're doing is when it's above the curve, you're just integrating the function if you want the region bounded by the curve and the x-axis. If the region is below the x-axis, you're still just integrating the curve, but you're doing the opposite of it because you're going to get a negative integral for when your curve lies below the x-axis. Okay, so we're just going to put this whole thing on the calculator, and I'm going to take advantage of the vars function on our calculator because we've already graphed this. So if you look, for me this is F10. Okay, so F10 of x. So I'm going to go to a calculator page, and I'm going to hit the key to the right of the 9. There's our integration template, and I'm going to go from -3 to 0, and I'm going to hit F10 of x. And then I'm going to subtract 0 dx, and then I'm going to add, and we're going to do integral again, and this time we're going from 0 to 1, and I'm going to do 0 minus, and I'm going to go ahead and hit var, F10 of x again, dx. Okay, and you see that it's going to give me both areas added together. So we got 11.8 3 repeating. Let's see. I'm going to do menu number approximate to fraction. And that's also the same as 71/6. I'm going to tell you one more little trick that you can do if you are doing a calculator problem. This would be the same thing as if you just took the absolute value of this function. So if you took the absolute value of this function, and Elizabeth, I'll apologize for the pink, it would just look like this, only this part would turn up. Anything that's below the x-axis would just reverse. So here in pink, I've done the absolute value. So if you actually integrate the absolute value of the function, it makes all negative areas positive. Okay, so if I make all that pink, then I could find that same area if I just integrated over the whole interval. So I could integrate from -3 to 1 of the absolute value of this function, and that would take care of it, no matter which curve is on top or which curve is on bottom. In fact, I could subtract upper curve minus lower curve or lower curve minus upper curve, either order, if I took the absolute value of the difference of those two functions. So it's another way to handle it if you have the calculator function available to you. You cannot do that if it's by hand. You would not be able to create this absolute value function. So just to show you that that works, we'll go and we'll integrate the integral from -3 to 1, and we'll hit the key to the right of the 9 and hit the absolute value, and we'll do the var again, f10 of x dx, and you'll see that we get the same value. So that's an advantage if you've got your calculator. Okay, and if you'll look then, you're ready for your homework. And your homework is just this in your textbook. And hang on just a minute and I'll tell you which ones you can do with the calculator. Okay, bad news for you. Just checked, and all of these are ones that I need you to do by hand. In fact, the instructions on many of them tell you to solve algebraically. So please spend the rest of the time working together and solving this. And if you have any extra time, then you need to work on Cognity. Log in. You're working on the book and doing all the sections in the book. You can also work on your video review assignment if you have your headphones. Thanks.